So, angle relationships, we're also going to look at some triangle properties. First and foremost, common relationship among angles. When we have two lines that intersect, that vertex is going to create four angles. Within those angles, the ones that are opposite each other from the vertex, we call vertical angles. They are congruent in measure. They will be the same size. Same thing here. These two angles will be the same size. Those are our vertical angles. Another common relationship we have, if we take two parallel lines, remind me what parallel means. They never touch. We take two parallel lines and intersect them with a third line. That is called a transversal. That transversal is going to create 8 angles with that intersection. Now, within those 8 angles, we have several different relationships. We're going to go over those. First one is that we have vertical angles. So angles 1 and 4 are vertical, meaning that they are congruent. Angles 2 and 3 are vertical, meaning they're congruent. Angles 5 and 8, as well as 6 and 7, are vertical. They will be congruent. If I have a straight angle, what relationship is that?
Wait, where is the straight angle at?
Right there. They add up to 180.
Yeah.
What do we call that again?
Coterminal.
Now you're just throwing out random straight words. Supplementary. So 1 and 2 form a supplementary relationship. 2 and 4 are supplementary. 3 and 4 are supplementary. 1 and 3 are supplementary. So any of those angles right next to each other on the transversal are going to be supplementary. So they add up to 180 degrees. A couple other relationships. Okay? We've got alternate interior angles. Alternate means on opposite sides. Interior means inside. So alternate interior angles of the angles inside of our parallel lines, you would draw, thank you, okay, within the parallel lines, on opposite sides of the transversal, those are opposite interior angles. Opposite interior angles are congruent. Okay, opposite or alternate interior angles will be congruent. We also have alternate exterior angles. What does exterior mean? Outside. So opposite sides of the transversal, outside of the parallel, those will be congruent. Okay, so 1 and 8 are the same measure, 7 and 8, or 7 and 2 are the same measure.
How do you know when, so it's a supplementary angle, how do you know when to 180?
Because it's two separate vertices.
Okay.
So this is one straight angle, and this is a different straight angle, different vertices. We also have, what's the next one? Same side interior, okay? So same side interior on the inside, okay? So inside on the same side, those are supplementary. They will add up to 180 degrees. Okay? Same side interior, they'll be supplementary. Also, same side exterior. Those will also be supplementary. They will add up to 180. We talked about one. And then corresponding. It's the last one. Corresponding is when you look at the two vertices, any angle that's in the same position. So the top right angles, these are corresponding. The bottom left angles are corresponding. The bottom right angles are corresponding. The top left angles are corresponding. Those will be congruent. So when we're looking at a transversal, we're only going to have really 2 angle measures because so many of them are similar or supplementary. There's only going to be 2 numbers. So once we get those 2 numbers, we can use these different relationships to figure out what any and all of them are. So when we're looking at transversals, it's all going to be just two numbers. So we're given a transversal, a parallel line, and we're given some information about angle 1 and angle 4. So what type of angle relationship do I have with angle 1 and angle 4? Not corresponding because they would be in the same position.
Alternate.
Exterior. They're on the outside, on opposite sides. Alternate exterior. What do we know about alternate exterior angles? They're congruent. 3x plus 2 has to equal
5x.
Okay, solve for x. $21. Okay, so what's the measure of angle 1? X equals 21.
65.
How'd you get 65? And so we solved for x, substituted back in to find the measure of the angle. So 3 times 21 plus 2 gives me 65. Now with that information, what other angle or angles has to be 65 degrees? 4, because they're congruent, right?
Yeah.
So that also has to be 65. Are there any other angles that will be 65?
3.
Why 3? What do we call those types of angles?
Corresponding.
They're not corresponding. Nope.
It is alternate interior.
Actually, let me go back. Tyler. Which angles are corresponding?
1 and 3.
Not 1 and 3.
1,
2 and 3 are not corresponding.
3. I mean 3 and 4.
3 and 4 are corresponding. Very good. So 3 and 4 are corresponding, so they have to be the same. What do we call 1 and 3?
Opposite.
Not complementary.
Opposite.
They're kind of opposite, but we have a different word for it.
Alternate.
The very first one.
Alternate.
Very first one.
Central.
The very first one.
Vertical.
Vertical. 1 and 3 are vertical. Okay? 1 and 3 are vertical. 3 and 4 are corresponding. So those are going to be congruent 65 degrees. Okay? Alright? Now, 2 isn't congruent with any of those. So, 2 is supplementary with 1. Also with 3. Also with 4. Because they're same side exterior. Okay? And 1, 3, and 4 are all the same. So we have a supplementary relationship. Angle 2 plus angle 3 or 1 has to equal 180. So the measure of angle 2 is 115. All of those angles will either be 65 degrees or 115 degrees. So let's say this is angle 5. What's the measure of angle 5? 115, because it's vertical with 2. What's the measure of angle 6? 115. What's the measure of angle 7?
65.
What's the measure of angle 8? 115. So once you've got those two, you can use either the complementary, the vertical, the corresponding angles, any mix and match of those to figure out what each of those is. So now we're going to move into some triangle stuff. Pretty straightforward. Some of the measures of any and all angle of all the angles in a triangle are always 180. So angle 1 plus angle 2 plus angle 3 has to equal 180. So if I'm given two angles, what can I do with those to find the third? From 48 plus 61 plus measure of angle 3. So, what's the measure of angle 3? Alright, now types of triangles. We can classify them a couple different ways. Some things we can look at. To start with by looking at the angles. If all of the angles in our triangle are acute, we have an acute triangle. Remind me what acute means. Less than 90. So all three angles have a measure less than 90 degrees. That gives us an acute triangle. Right angle. What's a right angle?
That's a 90.
Say that again.
That's an angle that's 90.
Right angle is less than 90?
No, 90.
It is 90, yeah. So a 90 degree angle, acute, less than 90 degrees, a right angle, exactly 90 degrees, one right angle. Now, you cannot have more than one right angle. Because once you hit 90 and you add 90, you're already at 180, and you haven't added a third angle yet. Okay? So you can only have one right angle. What is obtuse? Greater than 90. Same as with the right angle, you cannot have more than one obtuse angle. But if you do have more than one obtuse angle, or if you do have an obtuse angle, it's an obtuse triangle. We can also classify using our sides. If all sides are equal, equilateral. Okay, lateral means sides. Equilateral, all the same. Equilateral triangle. Notice the tick marks indicate the relative lengths of the sides. If a side has the same number of tick marks as another one, they are congruent. So if the measure of this side was 10, then based on the tick marks, I would know that they are all 10. Isosceles, two sides are congruent, and then you can identify those if the numbers aren't given by the tick marks. If I know that this side is 10 and this side is 8, what's the measure of my third side? 10, because it's going to be congruent to the other one with one tick mark. And then scaling. No sides are equal. They'll all be different lengths. They all have different tick marks. We're going to be seeing these a lot, at least more than others. Similar triangles. Similar triangles have to satisfy both conditions. Now you'll find that if the first one's met, the other one is automatically, and vice versa. It can't be any other way. Corresponding angles have to have the same measure. What I mean by corresponding angles is when we're looking at two triangles. Yeah, they're different sizes. Okay? If we look at each individual angle, if the smallest angles of each triangle are the same, okay, the smallest sides will be corresponding. If the largest sides are the same, then the corresponding angles will be the same. All right? We can take two triangles of any size, okay, here and here, and if I know that the smallest angle, the right angles, if the smallest angles are the same, the largest angle, in this case being the 90, are the same, then I know the middle one also has to be the same, because there's no other way to add those numbers and get to 180. Then they're going to be similar. And this is important for the follow-up, where corresponding sides must be proportional. So the ratio of the side lengths has to be proportional all the way through. So if I have side length A and side length A, the ratio of those sides has to be equivalent to the ratio of all of the corresponding sides. Those ratios have to be the same. We'll have a proportional relationship. We'll use that information to solve various triangles. So we'll start with the angle relationships. Okay? Based on the diagram, which angle is corresponding with angle A? How do you know?
Because it's the same, just smaller.
It says 45. What if the numbers weren't there?
The line.
It's
The same little arc, right?
Yeah.
This one's got one arc. This one's got one arc. So those are corresponding, so they have to be congruent. They're going to be the same measure. They told us they're the same measure because they labeled them both 45. What angle corresponds with M? How do we know? It's got the 3 lines. So what's the measure of angle B? 31 degrees. Which angle corresponds with C? P. What's the measure of angle C? 104. Now, we don't have any angle measures, but we still have the demarcations, the little lines that indicate which angles are corresponding. So what angle corresponds with F? B. What angle corresponds with A? E with C. So the ratio of side AC, this side here, has to, and the corresponding side of DE has to be equivalent to every other corresponding side. So what side corresponds with CB? EF. Those are corresponding sides. So the ratio of BC over EF will be congruent to the ratio of AC over DE. And what side corresponds with AB? DF. So the ratio of AB over DF has to be the same as the other two ratios. So we can set up our proportional relationship to solve for any of those. So we'll start with ACDE because we know side DE. All right? So we have 16 over 8. All right? And then let's do DF. So DF and AB are the ratio. So 24 has to be proportional with DF. Let's use a variable just to make it a little bit cleaner. Let's label this side X. The ratio of 16 over 8 has to be equivalent to 24 over X. What can I do to solve for X? Multiply. So we're going to multiply both sides by 8X. On the left, we're left with 16X. On the right, what's 8 times 24? I was thinking a different. I don't know. I was thinking a different one. I was thinking of the other multiplication. Say 192. Alright, my apologies. I was thinking X equals 12. Alright. So side length DF is 12. We can set up another proportion and do the same thing. We have 16 over 8. Set it equal to 32 over X. Cross multiply, solve again. Now, the proportion will always work, but sometimes we can see a relationship from one triangle to the next. If we look at the corresponding sides, 16 to 8, 24 to 12. What's the relationship from the big triangle to the little triangle? So you can use that information if you can recognize, hey, that's half the size on each of those. We can do the same thing to get that. Question?
No, that's what I was
It won't always be that neat and clean, so that's why I want you to know how to set up the proportion, because maybe it's not half as big. Maybe it's 0.8 more or point or something else. Okay, so you need to be able to set up the proportion relationship. Okay, but if you recognize that relationship and you know, okay, this is 2 times as much or 3 times as much, then by all means, go for it. Okay, you just need to make sure that you're matching up the corresponding sides correctly. Last thing I want to talk about is when we're given application. If you're not given a diagram, draw one. Even if it's just 2 triangles and you kind of label. Because if you're trying to keep track of all the different sides of the different triangles without something visual, then the chances of mixed around is pretty high. So we're given firefighters at a station need to measure the height of the station of flagpole. they find that the instant when the shadow of the station is 18 meters long, so the shadow on the ground, the fire station is 18 meters long, the shadow of the flagpole is 99 feet long. Those shadows will be corresponding sides, okay, because they're both the shadow cast by an object. The height of those objects will also be corresponding sides. So the height of the flagpole will correspond with the height of our station. All right? So, what's our proportion going to look like? Okay, 18 over 99. Those are corresponding sides. Has to equal what? Yeah, so let's just label this X or whatever, H, something, so it's nice and easy. 10 over the height of our flagpole. When you're writing the proportion, make sure that things kind of match up with each other. So if we look at the corresponding sides, those form the same fraction. The corresponding sides form the same fraction. Bigger triangle is on the same side of the fraction, and then small side again. So 18 and 10, those are on the same side. They're both the numerator. 99 and X, those are both the denominator. You can flip that ratio if you want, but it still has to match up. You could also write this as 99 over 18 as long as you write it as X over 10. Either one's fine. Doesn't matter. Yeah.
Wait, so once you find the height of the pole, you don't need to find the other one?
Nah, we'll do that later. Yeah, but you could then use Pythagorean theorem, but that'll be...
Like
if we were given another side, we could do it. But here we just need the height of the flagpole, right? Find the height of the flagpole. Find the height of the flagpole. Say again. So no matter how you slice and dice it, X is 55 feet. Okay? Questions, comments, concerns, queries, conundrums. Okay? Chapter 14 is quick. So